Right, so just in case you've been hiding in a hole somewhere for the last few years, what is fracking? Well, fracking is a well that's drilled a bit like a water well to a depth of 2,500 to 5,000 feet. This is where its relationship to a water well ends, because the drill then changes direction to the horizontal, making the end bore an L shape, which is up to 2 miles long. Then between 100 and 350,000 gallons of water, sand and secret chemicals are pumped in. The fluid is pressurised to between 10,000 psi and 15,000 psi, that's pounds per square inch. The pressure is released and 70% of the fluid is pumped out. The rest stays in, can't be extracted. And the rock around the horizontal section of the bore should now be riddled with tiny cracks. But what about already existing faults? Now, any existing large or small fault that happens to intersect the bore obviously will also be pressurised, and it's very difficult for geologists to find these faults between 2,000 and 5,000 feet underground. Now, some old faults will already have been closed by the compression of the ground, and they'll merely exist as weaknesses to be opened up. Other once active earthquake faults will be stable due to frictional forces. And we say to ourselves, but surely a bit of pressurised water cannot cause even a small quake. Well, my conjecture is that it certainly can. The maths is simple enough for you to follow, and hence I cannot really believe the frackers have not worked this out years ago. Here we go then, step by step. Now, how much a cubic foot of ground weighs is not as simple as you think, since there are many different densities of rock in a slice of the earth. But we know that oil shale, which is the rock that they're aiming for to crack, weighs around about 162.3 pounds per cubic foot. So let's be charitable and say it's that density all the way up. I mean, most rocks found with shale will be lighter. If you want to know the densities of different rocks, then you can look at edumine.com. So now we know that 162.3 pounds will lift a foot of oil shale. Now, fracking pressures vary from 10,000, which is the minimum pressure I could find, to 15,000 pounds per square inch. So let's work out for the lowest stated figure, being charitable. There are 144 square inches in a foot, so 10,000 times 144 is 1,440,000 pounds. Yes, for every square foot of fault area, we produce nearly 1.5 million pounds of thrust, and that's at the lowest pressure. So how deep a column of rock can we lift? Well, we said the average weight of the rock was likely to be less than 162.3 pounds per cubic foot. But people can always argue with that and say, oh no, it wouldn't do that. So let's take the absolute worst case of basalt, which is about the heaviest rock you can get, and say it goes all the way down from the surface right to the bottom of the well at 187.2 pounds per cubic foot. So 1,440,000 divided by 187.2 is 7,692 feet depth of rock. And the role of proppant in quakes? Well, mixed with the chemicals in the pump water is a substance that they refer to as proppant. And this is simply sand with a controlled size that props the cracks open. However, when an existing fault that is friction locked gets propped open, the sand may act as a lubricant. See the film in a moment. This reduction of friction may cause new quakes if stress on the fault is still present, or if it's actually built up due to fracking. Now here's a simple little experiment to show how proppant causes the earth to slide and quake. Now let's say the board is one stratum of rock and the brick is the rock above it. So you can see we'll lift the board, and when we get to a certain angle the brick will begin to move. Now And we're now about 30 degrees, about 40 degrees, about 45, yeah, about 42, 43 degrees, the brick moves. So now, let's introduce some propellant. Propellant in real life is sand. I'm going to use salt. It's just grains of something. That's all propellant is. So there we put a few grains of our salt on. And we put the brick back again. The same place. Once again we'll lift it slowly until the brick moves. That's not even 20 degrees. So you can see that the presence of propellant will make a huge difference to the friction between two pieces of rock. So yes, we scan. The well depth is stated at between 2,000 and 5,000 feet, and with the lightest quoted pressure and the heaviest possible rock, we can lift 7,692 feet of it. So this means even if a fault is horizontal, then this can happen. If the fault is vertical, the process is even easier. Remember, if the process fractures a rock, then the rock must move sideways to make room for the new cracks. So as far as I'm concerned, this is proven. Fracking can lever open old earthquake fissures and destroy their friction lock, and thus their stability. There is more than enough force to do this. Now let's just hope nobody tries the technique out anywhere nasty. Thanks for watching this video. Please rate and subscribe.